All right, so when we're looking to find the average rate of change on a table, I like to label my x1 and my x2, and then my f of x1 and my f of x2. All of the information is there. I just have to identify it and then plug it into my slope formula correctly. Okay, so I'm given the interval starting when x is 0 to when x is 4, right? So those are my two endpoints. I'm going to call this my x1 and this one my x2, right? So right now 0, right? When x is 0, this is going to be x1. When x is 4, it's going to be x2, which means f of x1 will be 3 and f of x2 will be 35. Okay. So what was that slope formula? It was f of x2 minus f of x1 all over x2 minus x1, right? That was my formula. So all I have to do is make the substitution for each one of those variables, and then I can solve it. I can find the average rate of change. Okay. So f of x2, what is f of x2? F of x2 is 35. So 35 minus f of x1. What is f of x1? F of x1 is just 3. So my numerator consists of 35 minus 3. Now x2. What is x2? X2 is 4 minus x1. X1 is 0. So in order to find that average rate of change, 35 minus 3 is just 32 all over 4. And luckily 4 goes into 32, right? So we can completely reduce this and get a whole number here. 32 over 4 is going to be 8. So the average rate of change over the interval 0 to 4 is 8. Okay. So the table is not too bad. It's actually pretty easy. Any questions? Okay, let's do one more, right? Just so we get a feel for it. But I don't want to have to do all 4. You can, the other 2, I'll leave for you to do kind of like additional practice on. All right. So let's talk here. Let's do example B. Okay, let's do example B. Yes, so for A, yes, A is 8. Average rate of change is 8 between the interval 0 and 4. Right, so this is always good to have. That indicates where that average rate of change is happening from. Okay, so you leave the interval there. All right, I'm going to erase all of my information because I'm going to have a new x1, a new x2, a new f of x1, a new f of x2. Okay, so I'm going to label it this time. I'm going to do it in red. So here's my x1. My x1 is 1, right? That's x1. And my x2 is 3. So what does that mean? That means that f of x1 will be 8 and f of x2 will be 30. All right, and then same process, right? Same formula. F of x2 minus f of x1 over x2 minus x1. Okay, so let's go ahead and highlight, right? F of x2, this time f of x2 will be 30. So I get 30 minus f of x1, that's 8. So 30 minus 8 all over my x2. X2 is 3 minus x1, which is 1. So we arrive at 30 minus 8, 22. 3 minus 1, 2. So 22 over 2, that ends up being 11. All right. So we have an average rate of change of 11 between the interval 1 and 3. Where did I get 8 from? It's just 32 divided by 4. It simplifies to the whole number 8. Okay. So between A and B, right, those two intervals, 0 to 4 and 1 to 3, where is the average rate of change larger? Yeah, the second one, right? In the second interval, 1 to 3, we have a faster average rate of change, right? So maybe in between 1 and 3 seconds, somebody was like sprinting, right? They were sprinting as fast as they could, maybe. All right, question. So if the numbers are not divisible, do we still divide despite there still being decimals? In some cases, you might need to, if you're being asked, where is the average rate of change is the largest? And you might need to convert that into a decimal so that you can truly compare the size of the numbers. Okay. Right. So that, and then typically when you have average rate of change, you want the unit in the denominator to be 1. So you want to divide it all the way through. Okay. Kind of. And the reason why is like this, right? Like nobody says 5 miles per 3 hours, right? Like that no one really does that. It's a certain mile per 1 hour, or like meters per second, or feet per second, not 12 feet per 5 seconds. That's like, okay, that's helpful, but I want to know like what is what we call the unit rate, right? So 8 is the unit rate, 11 is the unit rate. Okay, it becomes more applicable when you have like an actual scenario of somebody running, right? You want to know the unit rate, which is like the most simplified version of like how fast are they going, right? So typically with average rate of change, we do divide it all the way through. Okay, so that tends to be like with applications. There will be at times though where it's like, let's say you have the graph, right? Let's say some of these didn't divide all that great, and you ended up with maybe like 4/7 as a rate of change, right? But it's abstract, right? It's abstract. There's really no indication that this is like a race or nobody's running, right? So in that case, it's a little more acceptable to leave the slope as a fraction when it can't be reduced any further. Okay, but anytime you have like a real life situation, you typically want to break it down to the unit rate, right? And then we'll get to those probably on Monday where we'll do some more applications of it. Right now, it's just all kind of abstract. All right. Any questions on A or B? So far, so good. We know how to identify from the table. Cool. Okay. Okay. So you'll see tables where you have X and f of X along kind of like on rows, right? Here's another way that the table might show up. Right now you have X and Y. Right. So remember when I showed you that there's like 3 different formulas and they all represent slope, and you want to know that all 3 mean the same thing? That's because sometimes you might be given f of X, sometimes you might be given Y, right? So you want to be able to kind of switch between which formula to use depending on what I'm given. So if I'm given X and Y, then now my labels are going to be X1, Y1, X2, Y2, right? Instead of X1, f of X1, right? And then take a look at this. Find the average rate of change between, look at the way in which it's given to me this time. What does it represent? What is it telling me? Yeah, it's the notation. So what 2 X values am I going to use? Which one will be my X1? Which one will be my X2? Right, okay. So this is nice. I like to think of this as, okay, that means they're giving me my x1, that's the first number. And then they're also giving me my x2, that's the second number, because those are the x values. Right. They give me the same information as before. It's just in a different way. All right. So let's find the average rate of change between the interval -1 and 3. Okay. So I labeled it this way because now I know, okay, -1 is my x1, 3 is my x2. So then that also means -11 will be my y1 and -27 will be my y2. Okay. So labeling is the most important part because then from there, it's just plugging in into the formula for slope. So we know that slope can also be written this way. Y2 minus y1 over x2 minus x1, right? This is the most familiar probably from algebra 1. So let's just make sure that we substitute in the correct place. Y2 is -27 minus y1 is -11. All right, so if that's minus -11, I need parentheses -11. X2, that's 3. X1, that's -1. Okay, so that'll be 3 minus -1. So just be careful with some of those double negatives, right? Easy to make mistakes here. But ultimately, what is this saying? Well, this is negative times negative, that's a positive. So that's -27 plus 11. And then negative times negative, that's 3 plus 1. Right, so -27 plus 11 would give us -16. 3 plus 1 is 4. So my average rate of change is actually going to be -4. And that's okay. If 3 was -3, would the average rate of change be 8? Yeah, it would. But then your interval changes, right? We'd be talking about a different interval. But since we don't have the information about -3, but right, according numerically, yeah, it would be. Okay, any questions there? Any special cases? Not necessarily. Not really. Okay, so let's try one more just to make sure that we feel comfortable. All right, now we're being asked, find the average rate of change between this interval, right? So then what information am I given? What's my x1? What's my x2? Right. X1 is -2 this time, and x2 is 3, right? So now we want to know the average rate of change over the whole table, right? -2 is my first x value, 3 is my last x value. Let's find the average rate of change between the whole thing, okay? So if this is going to be x1 and x2, this will be y1 and y2. So formula. Y2, -27, minus y1, -22. X2 is 3, minus x1, -2. So let's go ahead and clean this up. That ends up being -27 plus 22. Distribute here, negative times negative, that's 3 plus 2. So ultimately, we're getting -5 over +5. My average rate of change will be -1. right, any questions there? So if you look at it over the whole interval, pretty slow, right? Rate of change is -1 versus on the first interval, it was a much faster rate of change. All right. And now the last one, and probably the most, not challenging, but maybe the most work, okay? Because so far, pretty much in every scenario, you have been given the y value, right? Either in a table, in a graph, right? We can see the y value there. Even before, right? The very, very beginning, right? We were given the y value because they gave it to us as a coordinate, right? So we had the y value every time. This is the most challenging type, the last one, okay? Because you're only given the function. Okay, now obviously this is under the assumption that you don't have a graph, right? If you did have a graph, this would make it a lot easier, but you only have the function. So I have to work with this because I need to find the output. Correct. So it's not hard, it's just more work, right? So what do we need to do? We need to plug in our input to find out what is the output, find out the f of x value for that particular x, okay? So remember, when you're given the interval in this way, this simply means that x1 is -1 and x2 is 4. Oops, yeah, x2 is 4. All right, so I need to find f of x1, right? What is f of x1? Well, isn't that the same thing as f of -1? So I'm going to plug in -1 into my function. So I would get 3 times -1 squared is minus -1 minus 2. Right? I have to find the output value so that then I can use it in my formula. Okay. We'll clean up. -1 squared is a +1. And then +1 times 3 is 3. Negative times negative is positive, and then minus 2. So my f of -1 ends up being 3 plus 1, 4 minus 2 is 2. So x1 is -1, f of x1 is 2. Okay. So I have it for x1, f of x1, right? I have that first pair. Now I have to do it again for x2. Okay, I need to know what is the output when x is 4. Okay, so we repeat the process one more time. Right, we want to know what is f of x2. Well, f of x2 is like saying f of 4. So we're going to plug into the function 3 times 4 squared minus 4 minus 2. So let's take the power here first. 4 squared, that's 16. 16 times 3 is 48. Minus 4 minus 2. So 48 minus 4 is 44, minus 2, 42. Okay, so f of 4 is 42. So that means x2 is 4, f of x2 is 42. Okay, now we're ready to find the average rate of change. Okay, so there was a lot of work involved just to find the outputs, right? The f of x1 and the f of x2, right? A lot of work just for that. Now we can actually find it using the slope formula, okay? So slope formula, f of x2 minus f of x1, x2 minus x1. So f of x2 would be 42 minus 2 all over 4 minus -1. So what does that give us? That's 40 Negative times negative is positive. That ends up being 4 plus 1, so that's 5. So my average rate of change is just 8. Okay, any questions there for part A? A lot more work though, right? You didn't think so? Okay, that's good then. Good. All right, let me have you try part B. Let me have you try part B on your own, okay? And then we'll just compare answers. All right. So go ahead and do that.